Assalamu alaikum, brothers and sisters. Welcome to the journey of Quest, where we quench your thirst of knowledge. Have you ever wondered how minerals maintain their uniformity even when composed of different elements? Minerals, the building blocks of rocks and much of our planet, are an intricate dance of elements that come together to form a diverse array of structures. Today, we're exploring the concept of solid solutions and exsolution, two fascinating processes that occur in minerals, adding to their complexity and variety. Imagine a cocktail party where guests mingle and interact in a single room. In the mineral world, this party is a solid solution. It's a homogeneous mixture where different elements, the guests, share the same crystal structure, the room. They move around, swapping places, but the overall structure remains constant. This is how minerals maintain their uniformity even when they're composed of different elements. Now let's turn our attention to Exsolution. Picture the same party, but as the night wears on, groups of guests begin to separate, forming distinct clusters within the room. In mineral terms, this is exsolution. It's a process where a solid solution becomes unstable and separates into two or more distinct mineral phases. This often happens when the mineral cools or experiences changes in pressure. Understanding these concepts isn't just for the geology students among us, it's for anyone with a curiosity about the world beneath our feet. The processes of solid solution and exsolution are key to understanding the formation, composition, and diversity of minerals. They reveal insights into how our planet has evolved over billions of years and give us clues about processes happening deep within the Earth. But we're not stopping here. We're going to delve even deeper into these phenomena, looking at what causes them, how they affect the properties of minerals and why they're important. From the gems in our jewelry to the granite in our kitchen countertops, these processes are at work, shaping and reshaping the world around us. So let's dig deeper into these fascinating concepts of solid solution and exsolution. Imagine a scenario where one mineral can replace another within the crystal structure without changing the mineral's outward appearance. Welcome to the fascinating world of solid solutions. It's a bit like a game of musical chairs, but with minerals and their crystal structures. Let's delve a bit deeper into this concept. In a solid solution, one mineral can take the place of another in a crystal lattice without altering the lattice's overall structure. This replacement happens because the substituting mineral has atoms that are roughly the same size as the original mineral's atoms. The similar atomic sizes allow the replacing mineral to fit snugly into the lattice without causing any structural changes. Think of it as a puzzle where one piece can replace another, as long as they're the same shape. The color, texture, or pattern of the puzzle piece may be different, but as long as it fits into the spot, the overall picture remains the same. Now you might wonder, why does this matter? The beauty lies in the fact that even though the crystal structure remains the same, the properties of the minerals can be vastly different. This means that the chemical, physical, and optical properties of the original mineral and the substituting mineral can vary significantly, yet they still fit into the same crystal structure. Let's take an example. In the mineral olivine, the iron and magnesium ions can freely substitute for each other. This substitution creates a range of olivine varieties with different proportions of iron and magnesium, each with unique properties, yet all maintaining the same crystal structure. This ability to substitute allows for a wide range of mineral compositions and properties within the same crystal structure. It's an incredible natural phenomenon that showcases nature's adaptability and diversity. So in essence, a solid solution is like a mineral masquerade, where one mineral can disguise itself as another. It's a dance of atoms, a ballet of elements, where the performers may change, but the stage remains the same. Now, what if I told you that sometimes minerals decide they no longer want to share their crystal structure with other minerals? Yes, that's right. This intriguing process is known as exsolution, and it's a fascinating phenomenon indeed. Exsolution is the reverse of a solid solution. In simple terms, it's when a homogeneous mineral decides it's time to go solo and separates into two or more different minerals. Think of it as a mineral equivalent of a band breakup. The members, or in this case the minerals that once harmoniously shared a crystal structure, decide to part ways. This process doesn't happen on a whim. It's often driven by changes in temperature or pressure. Sometimes, the conditions that once made it comfortable for minerals to share a crystal structure change. When the temperature drops or the pressure shifts, the situation may no longer be ideal for cohabitation within the crystal structure. It's like when you and a friend decide to share an apartment because it's convenient and cost-effective. But later, if the rent increases or if the apartment becomes too cramped, you might decide it's time to move out and find your own place. That's essentially what happens during exsolution. As the temperature or pressure changes, the minerals find that sharing a crystal structure is no longer beneficial. They become unstable and start to separate. The original mineral, now split into two or more minerals, begins to alter its internal structure. This process can lead to the formation of new, fascinating mineral structures. But why does this matter? Well, the process of exsolution can significantly affect the physical properties of the mineral, such as its color, hardness, or even its magnetic properties. It's a process that demonstrates the dynamic nature of our planet's interior, shedding light on how even the smallest changes in conditions can lead to significant transformations. So, through exsolution, a mineral can decide to reclaim its individual identity, leading to an interesting mineralogical transformation. It's a captivating example of nature's remarkable adaptability and the ever-changing world beneath our feet. But why should we care about these mineral masquerades and identity crises, you may ask? Well, the importance and applications of understanding solid solution and exsolution are far-reaching and profoundly impactful. These processes can dramatically affect the physical properties of minerals, which in turn influences their uses and behaviors. For instance, the process of solid solution can cause significant changes in the hardness, color, and even the electrical and thermal conductivity of minerals. This is because the different elements involved can introduce variances in these properties, making the minerals more versatile for different applications. Consider gemology, the science and study of gemstones. The color variations we see in gems, such as the mesmerizingly diverse hues of sapphires, can be attributed to the process of solid solution. Different elements substituting into the mineral structure can create a spectrum of colors, making each gem unique and valuable in its own right. Then, we have the realm of materials science, where understanding these processes can lead to the development of new materials with specific properties. By manipulating the conditions under which solid solution and exsolution occur, scientists can engineer materials with tailored characteristics, suitable for various technological applications. Lastly, we turn our gaze to earth science. Knowledge of solid solution and exsolution processes can provide valuable insights into the geological history of our planet. The presence of certain minerals and their exsolved counterparts can tell us about the conditions that existed when they formed. This information can help us piece together the geological puzzle of our Earth's past, contributing to our understanding of climate change and even aiding the search for natural resources. So, understanding the dance of elements within minerals through solid solution and exsolution, we can better comprehend the world beneath our feet. These complex processes are not just academic curiosities, they are the keys to unlocking the mysteries of our planet and paving the way for advances in numerous fields. So, what have we learned from this mineralogical journey? We've delved into the intriguing world of solid solutions, understanding how different elements can coexist in the same crystal structure. This phenomenon allows for a vast variety of minerals, each with unique properties, and helps us understand how minerals adapt to changing conditions. Then, we explored the concept of exsolution, a process where a homogeneous solid solution separates into two or more distinct crystalline phases. This process, often occurring over geological timescales, has a profound impact on the appearance and properties of many minerals. We also touched upon the significance of these concepts in the broader field of mineralogy and petrology. They not only enhance our understanding of the mineral world, but also have practical applications in industries like gemology, material science, and geotechnical engineering. Remember, the world of minerals is not just about pretty crystals, but also about the fascinating processes that occur within them. Keep exploring. Thanks for watching us share our videos. Subscribe our YouTube channel and press the bell icon and stay curious for new uploads.